Problem number 15. A figure shows three forces applied to a trunk that moves leftward by 3 meters over a frictionless floor. The force magnitudes are F1 equal to 5 Newton, F2 equal to 9 Newton, and F3 equal to 3 Newton, and the indicated angle is theta equal to 60 degree. During the displacement, what is the net work done on the trunk by the three forces? And the second question, does the kinetic energy of the trunk increase or decrease? So here we have to see the given diagram, given figure. So here we have a block of trunk, and on this trunk we applied three forces, F1, F2 and F3. And when you apply these three forces, what happened to this trunk? The trunk moves leftward direction. That means in this direction the trunk is moving. By that it have a displacement of 3 meters. So that means the D value here they mentioned as 3 meters. And now what we have to do, we have to find the net work done based on these three forces. So that means we have to find what is the work done by the first force, what should be the work done by the second force, and what will be the work done by the third force. After we find W1, W2 and W3, we have to find the net work done. That is the answer for the first question. And after we find the answer, based on the answer, then only we can give the answer for the second part. So first of all, let's write the given first. The magnitude of first force, which is 5 Newton. The magnitude of the second force, which is 9 Newton. And then the third force magnitude is 3 Newton. And then angle, which is applied for second force, theta equal to 60 degree. Now we have to apply the rule which we already studied. Work done which is equal to FD cosine theta. This is the rule. So what we have to do, we have to apply this rule for each force. So let's start with the first force. So what is our first force? So here for first force, W1 which is equal to F1 multiplied by D cosine of theta 1. So what is cosine of theta 1? Because here I have to mention the angle number because we have three forces. So for first force I have to substitute the value of theta as theta 1, for the second force which is theta 2, for the third force which is theta 3. Okay, so let's find the angle for theta 1. So theta 1 is very important. You can see the first force. The first force is acting in the leftward direction. By this trunk is moving in the leftward direction. That means the displacement direction as well as the first force applied direction is also in the same direction. Therefore the theta 1 which is equal to 0 degree. Clear? Now I have to substitute the value. F1 value is 5 Newton multiplied by the displacement is 3 meter multiplied by cosine of 0 which is equal to 1. So by that we got the answer here as 15 joules. So which is W1. Likewise, we have to find for W2. So what is W2? F2 multiplied by D cosine of theta 2. But here the most important thing is theta 2. You can see the object, after you applied F2, the object, the trunk is moving in the leftward direction. That means the angle we have to find here is this angle. So what is this angle? 180 degree minus theta. So that means 180 minus 60 degree we got here as 120 degree. Clear? Because why we use this angle? Because after you applied F2, the block is moving leftward direction. That means we have to find the angle between F2 as well as the displacement D, because the displacement is also in this direction. So we have to find the angle between F2 and the displacement D. So that's the reason we have to find the angle for theta 2, 180 minus 60. So by that we got the angle here as 120 degree. So now I have to substitute the value here. F2 value is 9 Newton multiplied by D value is 3 multiplied by cosine of 120 degrees. So let's see what is the answer. So 9 multiplied by 3 multiplied by cosine of 120. I got the answer here as minus 13.5. So the answer for W2 is minus 13.5 joules. Now we have to find the answer for the third work done for F3. And here it's very easy. You can see the object is moving leftward direction and your force applied F3 is the downward direction. That means the angle between D and F3 is 90 degree. So cosine of 90 degree, which is equal to 0. So W3, which is equal to F3 multiplied by D cosine of theta 3. So here theta 3, which is equal to 90 degree. Why 90 degree? Let's go back to the diagram. You can see F3 downward direction, the displacement is in the leftward direction. So the angle between F3 and D is 90 degree. So cosine of 90 degree, which is equal to 0. Anyhow, whatever the number multiplied by 0, we got the answer as 0. So let's substitute the value for F3. F3 is 3 Newton. Multiplied by the displacement is 3. Multiplied by cosine of 90 degree, which is 0. So anything multiplied by 0 is 0. So W3, which is equal to 0. So the answer for W3 is 0 joules. Once we find W1, W2 and W3, we have to find the net work done. That is the answer for the first question. So net work done, which is equal to W1 plus W2 plus W3. Now I have to substitute the answer for W1. What is the answer for W1? 15 joules plus, and what is the answer for W2, which is minus 13.5 joules, and then the answer for W3 is 0. So 15 minus 13.5. Why minus? Because plus into minus is minus. So we have to subtract the value of 13.5 from 15 joules. So 15 joules minus 13.5. We got the answer here for the net work done as plus 1.5 joules. So the answer for the net work done is positive 1.5. Now what I told you, we have to answer for the second question. What they asked in the second question, does the kinetic energy of the trunk increase or decrease? What I told you earlier, the answer for the second question is depend on the answer for the first question. So let's go back to the answer for the first question. What is the answer? We got 1.5 joules. So here we got this answer as positive value. If you got the positive answer, the kinetic energy is increased. If you got the negative answer, the kinetic energy is decreased. So what should be the answer for the second part? The kinetic energy here is increase. Why increase? Because we got plus 1.5. That's the reason we gave the answer here as the kinetic energy is not decreasing here. The kinetic energy is increasing because the net work done is the positive value of 1.5. So this is the answer for part B. That's it. Thank you.